Thank you for joining our session today on ReCap in the oil and gas industry. Today we have with us Cody Austin. He's a technical account manager for our oil and gas group. He's going to be running through some of the things that you can do with our product line, some of the advantages to using reality data in your workflow. Um, if you have any questions, if you're familiar with GoToMeeting, you can type in your question box to ask questions. We'll have some dedicated time at the end of the session for QA. Other than that, we'd love to hear more from you guys. If there are specific topics you'd like to hear us cover, we're looking to turn this into a series and go more in depth into some of these issues. If you have specific comments, questions, feel free to reach out to us. Shoot us an email, recap.community@autodesk.com. If there's a session you'd like to hear about in the future, if you'd like to present something, feel free to reach out to us. We love to hear from you. It's always great feedback. You can see here a list of some of the other places that you can find information about us. Recap.autodesk.com will give you access to download ReCap, play around with it. It'll have all sorts of videos and other things. As always, this session is being recorded and we'll be posting this on YouTube afterwards. Because of the holiday this week, that may not happen until sometime next week, but we'll get that up on YouTube. Other than that, I will hand this off to Cody.
Thanks, Eric. Can you hear me okay?
Yeah, everything sounds good.
All right, great. Hi, everybody. I just want to introduce myself real quick. My name is Cody Austin. As Eric mentioned, I'm a technical account manager here. Working in our oil and gas group, I work directly with some of the major owner-operators and EPCs in the oil and gas space. I'm based in Houston, Texas, and I have about 9 years of experience in the oil and gas industry. I got my start working for a construction company doing QA/QC inspection work at a number of turnarounds and shutdowns here in the Houston area. Then got into laser scanning, working for a service provider and a software vendor, and then got working more closely with some of these software vendors out there in the market. And today I've been with Autodesk for about 2.5 years. Feel free to contact me if you have any questions about today's presentation, any thoughts and ideas. As Eric mentioned, we're really looking for your feedback, and the functionality and workflows that you're going to see today are really driven by customer feedback, so that's very important. And below is my LinkedIn information if you'd like to connect with me. But first, I'd just like to quickly just talk about why reality capture is important to oil and gas. I think the oil and gas industry has really been leading the way with reality capture, especially laser scanning. It's been around since the late 90s, early 2000s. But the reason people have been using it on oil and gas projects is because, as you know, a lot of these assets out there are very old. Some of them are over 100 years old, and they may not have very much documentation. They may have things on that were drawn in pencil and paper, Mylar, or maybe even no documentation at all. So you really need to be able to quickly capture the as-built status of these existing facilities. Sometimes, if you do have existing as-built documentation, your confidence in it really isn't that high. Things change all the time in these facilities that we're working in, and those changes may not be pushed back into the as-built documentation that you have, whether it's 2D drawings, 3D models, and so your confidence is very low in those records. Sometimes these facilities are remote. They may be in Mozambique, for example, and getting to these sites can be very difficult and very costly. So capturing these facilities using techniques like laser scanning and bringing that as-built documentation back into the office, back into your design tools, allows you to really explore these remote facilities within the comfort and safety of your office. And that takes me to my next point. These facilities that we're working in, are very hazardous. There's lots of combustible gases and different types of chemicals sometimes in these facilities. So if we can limit our exposure to the field, we're obviously increasing safety. Rework is a major reason why people have kind of grasped laser scanning and reality capture. Before laser scanning came to market, traditionally you go out into the field with your tape measure, plumb bob, scaffolding harness, and take measurements, and take those measurements back into the field, design your piping, for example. And sometimes you may not have taken all the measurements that you needed, and when you went to install that piping in the field, it may interfere with something that was there. Obviously, that needs to be reworked. And if we can minimize that, we can increase your bottom line. Reality capture is becoming increasingly more cost-effective. The time in which it takes to actually capture the as-built status of these facilities is decreasing, as well as the cost for the hardware. The hardware, when I got into laser scanning about 7 or 8 years ago, was costing anywhere from $120,000 just for the hardware. But now today, vendors are offering hardware for $30,000, $45,000. So the price of the hardware has dropped tremendously. The last point I want to make is context. It's all about context. We're not designing facilities, or we're not working in projects in the vacuum of space. And this is typically how we start our projects, with a blank sheet of paper. But if we can bring in the context of our project into our design environment, as you see here, we're able to make much more informed decisions about where that piece of pipe is going to go, where I'm going to place that piece of equipment. We can take measurements within this environment here without needing to go out to the facility, climb up in the pipe rack, for example, take some measurements, and go back to the office. So we're saving a lot of time and a lot of money when we can reduce rework by bringing the facility to us. So I'm going to go into some of the ReCap applications. I'm going to first start off with ReCap Pro. And the Pro capabilities of ReCap allow you to actually register the individual laser scans together. So ReCap Pro would be used by somebody like a service provider who is actually going out into the field and collecting the laser scan data. I've noticed that some EPCs are starting to provide these services in-house, and so they have their own in-house teams of laser scanners that they can send out to the field and collect this data. So the ReCap Pro application is really targeted towards the service providers who are going out and collecting the data. One of the great features of ReCap Pro is targetless registration, which I'm demonstrating here. We're able to actually use the features within the laser scan data itself to align and stitch the individual laser scans together. We can import laser scan data from many different file formats. Here, this is some ZNF laser scan data that we collected out in Baytown recently. We can accept just about any laser scan format out there, from Faro to Leica to ZNF to Trimble to even XYZ data. And we don't just work with terrestrial laser scan data. We can also accept aerial LiDAR, for example. I'll show you how we can work with some of that data here in a second. I know a few of my customers are actually collecting subsea data using things like sonar and other acoustics to capture bathymetry data if they're doing maybe some subsea work, or if they're doing some piers, or really any type of work that happens either near or under the water. So we can really accept different types of files into ReCap Pro. And what you just saw there was actually a QA/QC report of the quality of the data that we've registered within ReCap Pro. So once we've registered the data in ReCap Pro, we can navigate around the point cloud. The next application I'd like to cover is Autodesk ReCap. So this particular product does not have the Pro registration features. It's the same exact product, it's just missing those particular features. But Autodesk ReCap is a free application that you can go and download today, and then you can bring in data that you've registered in ReCap Pro, or if you have data kind of sitting maybe on a server somewhere, you can bring that data into Autodesk ReCap, visualize it, and interrogate it in different ways. Here we are clipping the point cloud data, creating a few volumes within Autodesk ReCap. And we can save these volumes and save these view states, which I'll demonstrate here shortly. But what you can see from Autodesk ReCap, it's a very simple user interface. We've tried to keep it as simple as possible, and in fact, we've kind of optimized the user interface to be used on a touchscreen device. So one of the great capabilities of ReCap is that we can take it out into the field and use it in the field if we're doing registration, or if we simply just want to visualize the data out in the field. This particular part of the demonstration is demonstrating the use of view states, how we can save views within Autodesk ReCap, and quickly and easily get back to those saved views, as you'll see here. You may have seen some other videos similar that we've done in previous webinars, but I'd like to just show some of this functionality in the context of oil and gas. So here we're simply clipping the point cloud data. We're not deleting any of the points. We're just simply fencing off some points and removing them from this particular view. And again, we can save these views inside of ReCap for other people to view if we'd like. We can save this region. So we call it electrical boxes. You'll see I'll unclip the point cloud data. We can bring back our scan regions. You can see that those electrical boxes highlighted there in the view. So again, this is a free application. You're more than welcome to go to our website and download it. You also can download a free trial of ReCap Pro if you're interested in the registration features. But our customers are really using this as a great way to visualize point cloud data that they already have, or for those who may not be quite as technical as others, the user interface is really very simple. We're trying to democratize laser scanning data, put it in the hands of as many people as possible, and eliminate technical barriers, for example, that might keep them from leveraging the data. So here we're simply taking a few measurements within the point cloud data. And we're able to move the ends of these measurements if we'd like. I think that was a pretty nice feature that I noticed when I was messing around with ReCap. So as I mentioned, we're able to take measurements within ReCap without having to actually go to the field itself. Again, it increases safety, and you can only take so many measurements out in the field with the tape measure. Within ReCap, the amount of measurements you can take is almost infinitesimal. We're demonstrating the use of annotations within Autodesk ReCap. We're simply tagging these. We're annotating these pieces of equipment here. We can also add notes to these annotations. We can add hyperlinks to maybe websites, for example. I've noticed there's some YouTube videos on how to install actuators or possibly different procedures on maintaining different types of pumps, since we can easily add links to those within Autodesk ReCap. So here we are, still within Autodesk ReCap, but we're looking at what we call a real view. This is taken from the laser scanning data itself, from the laser scanner itself, and we're able to use this same exact view here to take measurements and add annotations as well. You can immediately see the differences between this real view and the point cloud data. The real view is much greater resolution than the point cloud data itself. But we are fixed to the position of the laser scanner. So you can see the laser scanner's shadow there in the video. We're actually sitting at the position of the laser scanner, rotating 360 degrees. And we can also view above ourselves as well. So in this real view, we can take measurements. We can also add annotations as well. So we can go back to our point cloud view, and you can see there the annotation that I've added inside the real view is also added back into the point cloud view as well. And lastly, we can actually upload this data to ReCap 360. So if we wanted to allow maybe our partners or different stakeholders, maybe our clients, access this laser scan data over the web, we can upload and push that point cloud data to ReCap 360. So I visited ReCap 360 at Autodesk.com. I've logged in. I've selected my ReCap project, and I'm able to view those real views over the web without the need for any additional installation of products. So it doesn't need any ActiveX controllers or any plugins. I'm simply using a WebGL-enabled internet browser such as Google Chrome or Firefox, and I'm able to visualize these real views over the web. I'm also able to take measurements and add annotations just like I was able to back in the Autodesk ReCap desktop application. This is a great way of sharing the laser scan data with your customers. You simply just provide them access to this project, and then they can sign in with their Autodesk ID, visit recap360.autodesk.com, and then they'll see that project there, and they can immediately go into it, take measurements, visualize it, and see really what was captured out in the field. So we have access to all of the different laser scans within the web browser that you see here. One of the other services that we have built on top of ReCap 360 is called Photo on ReCap 360. And a lot of people have really been excited about this particular service. It's a cloud-based photogrammetry service. You may have heard the term photogrammetry in the past, but it's kind of making a comeback thanks to the power of the cloud and being able to process this data very quickly. So I've logged into ReCap 360. I've told it that I want to create a photo project. I give them the project a name, and now I'm going to upload my photos that I've taken from the field to ReCap 360. So this is 75 photos that I've taken with a digital camera. I simply went up to the field, walked around a control valve in this particular case, and taken a number of shots. We have some really good examples and tutorials on YouTube showing kind of best practices for how to capture different assets using Photo on ReCap 360. So these photos have been uploaded to ReCap 360. I'm able to review these photos. I can also add scale to these photos as well through the Advanced Tools option. I can also do some manual registration if I'd like. I'm going to skip that for now. I'm simply just going to upload the photos and tell it to create me a model of this control valve. It takes a couple hours for it to do its magic, but once it's done, you'll get an email saying that your model is ready, and you're able to view your model over the web. So I'm using Firefox right now to visualize the end result of Photo on ReCap 360. Now, because I'm in a web browser, I'm only able to see a low resolution mesh of this model. So right now, it's only displaying 200,000 triangles in this mesh, but the full resolution model that I'll show you in a second contains 5.11 million triangles, and I'll show you how we can visualize the higher resolution mesh in a second. So again, we're able to visualize these models over the web, and we can give anybody access to these that you'd like and share them with your friends, colleagues, stakeholders. I know a few of our customers and my colleagues here at Autodesk are using drones to capture large areas, whether they be the civil site information. Some people are flying these around buildings, for example, and capturing photographs using drones from an aerial perspective, and then uploading those photos to ReCap 360 and creating these models. So here you're seeing a triangulated mesh of the data. So Project Memento is going to allow you to visualize and consume that high resolution, 5.11 million triangle mesh. This is a desktop application. It's a free application that you can download today. We can import and visualize many different file formats. The one I'm looking at here is an RCM file, a ReCap mesh file that was created from Photo and ReCap 360. You'll be able to see that the mesh is a much higher resolution mesh here in a second when I turn on wireframe mode. I'll zoom in, and you can see the density of this mesh. Lots and lots of triangles, lots and lots of detail that was captured from the photographs and automatically stitched together in the cloud, and I'm able to see this model on Memento. We can even see the details on the plate of that positioner there on that control valve. So Project Memento allows you to do some editing of the mesh. A lot of our customers are using it for 3D printing, so if I'd like to 3D print this mesh, I could. An example of that would be to possibly clip out this control valve from the mesh. And then there's some features within Project Memento that allow you to automatically detect any anomalies associated with this mesh. Maybe there's holes, maybe there's spikes, particles, tunnels, things of those nature that would keep this particular mesh from being watertight. And you need a watertight model for 3D printing. Photo ReCap 360 also allows us to export not just a mesh, but also a point cloud. So I brought that point cloud into Autodesk ReCap, the desktop application that you saw earlier. We're doing some of the same techniques that we were doing in Memento. We're simply just clipping this control valve out. And in a second, I'll show you some of the differences between the point cloud from a laser scanner and the point cloud from the photo mesh. So here we are integrating the point cloud data inside of AutoCAD Plant 3D. So we can take these models that were created with photographs and integrate those with Plant 3D or other applications, which I'll show you here in a second. So this is a side-by-side view of the same valve. On the left, it was collected with a laser scanner. So we have, you can really see the points more easily on the left-hand side. On the right-hand side is that same exact control valve, but it was collected using photographs. And you can see it is a point cloud, but there's so many more points in this model that you really can't see them. It's a much higher resolution model. And I've had customers ask me, can I replace my laser scanning workflow with a photo-based workflow? And in some cases, yes, it depends on your use case. How are you going to use the data? But in other cases, the photo on ReCap 360 really isn't going to be the best tool. You're really going to have to use laser scanning. One particular case is if you need to capture a large area, think an entire offshore platform or a chemical plant, you're not going to be able to capture all of that information with photography. Right now, photo on ReCap 360 is limited to 250 photographs, and so you're not going to be able to capture that entire asset with that many photographs and get really good quality results. Also, scale isn't inherent to the photographs, so scale has to be added after the photographs were taken. You can do that by taking some sample measurements while you're out in the field. Maybe I could have measured the distance between these two flanges on the valve body, for example, and push that information back into the photographs. Or I could have put maybe a yardstick or something that I could reference to take my measurements off of to give scale to this model. With laser scan data, scale is inherent to the data. So there are some pros and cons to using laser scan data, and some pros and cons to using photo-based automated photogrammetry workflows with photo on ReCap 360. And you just need to understand those pros and cons before you decide which particular tool to use. In the 2014 release of our Autodesk products, we introduced the new ReCap engine. If you've worked with point cloud data before in any of the AutoCAD products or any of our other Autodesk products, you may have noticed that you weren't able to see very dense point clouds. We didn't support color, and it just looked like a bunch of sand, and the performance really wasn't that good. In the 2014 and newer releases of our products, we have a new ReCap engine, which allows you to view much larger data sets at much higher resolution, supporting color as well. And I'll show you some of the differences between the old and the new. But The new ReCap engine is included in AutoCAD and other AutoCAD-based products such as Plant 3D, Civil 3D, Map 3D, AutoCAD MVP, for example, Advanced Steel, as well as Revit, Inventor, Navisworks, InfoWorks, and 3ds Max. But this is really going to allow you to bring in those large point cloud data sets into the design tools and design in context. So I'll show you a few examples here. This is Autodesk InfoWorks. What we're able to do in InfoWorks is to be able to quickly and easily create a conceptual model. So we're able to aggregate all sorts of information from visual elevation models and topos to aerial imagery from, for example, Google or Bing, Bing Maps from USGS, for example. Different types of GIS data, shape files, line work, also 3D models, and point cloud data. This particular video might be a little choppy over the web, so I apologize. We're simply just zooming in to our project location. This happens to be Baytown, Texas. But these models can be created using data that's available online or data that you can provide and collect yourself. Just going to jump forward a little bit. It's a little choppy. There. So I've zoomed into the project location and I've imported both my point cloud data and my 3D model into Autodesk InfoWorks. And so we're using, our customers are using Autodesk InfoWorks in the conceptual design phase of projects. We're using it to go out and win projects and evaluate different proposals. I apologize for the quality over the web. We're going to upload these videos to YouTube where you can view them on your own at a later time. I'd like to show you now is how we can integrate ReCap with Civil 3D. So a lot of my customers are asking, how can we turn point cloud data into a righteous Civil 3D surface where I can do different types of analysis, cut and fill, volume calculations, get profiles and sections for my projects. So here, what you're looking at now is I've imported some aerial LiDAR data into Civil 3D. So right now, I've just imported the raw data. I'm not using ReCap. This is actually how things used to look within our applications. Very sparse point cloud. You can kind of make out what's there. But the quality really isn't that good. So what we've done is we've associated that point cloud data to a surface, and we simply have drawn some contour lines over the surface, and now we can do things like volume calculations, cut and fill calculations, profile sections, those types of things within Civil 3D. So that was just using regular aerial LiDAR data that I found on the web. Now I'll show you the same workflow, but this time using the Autodesk ReCap engine within Civil 3D. So I'm simply going to attach a ReCap point cloud to my Civil 3D drawing, just like you would with an external reference. And immediately you'll be able to see the difference in the point cloud data. This is the same exact data that we were looking at just a second ago, but now we're actually utilizing the ReCap engine. If you have Civil 3D under subscription, there is a tool that allows you to extract surfaces from the point cloud. And so I'm utilizing that tool. I'm going to add a contour style to my surface. I've selected my point cloud data, and now we'll take a look at that particular surface a little bit closer. We'll change the style, maybe turn on the minor and major contours, and take a look a little bit closer. So whether you're collecting this data yourself, whether it's been supplied to you by your client, or whether you found it out there on the web, we can really leverage that data within a number of our applications and start to make use out of it. So now we see here a triangulated surface of that aerial LiDAR data. Turn the triangles off so you can see the contour lines a little bit easier. Alrighty, moving on. As I mentioned, designing in context is very important. If we can bring the what's out there in the real world, the as-built status of our project into different design tools like Civil 3D and Plant 3D, and design in context, we can make much better decisions and be more confident in our design before we actually move to the fabrication and construction stages of our project. So here I am in Plant 3D. I've simply attached a point cloud, just like I would, again, with the external reference file. A simple attach command like you saw in Civil 3D earlier. And we have a few functions that are associated with point cloud objects inside of AutoCAD. We can change the point size, level of detail, change the way the point cloud data is colored, and we can do different types of clipping commands within Plant 3D, as well as the other AutoCAD-based products. So I'm simply going to route a pipe from the discharge nozzle of that pump in the lower left corner. I'm going to tie into the header there. So we have a few Autodesk partners that have built applications on top of AutoCAD Plant 3D, which allow you to reverse engineer or back model the point cloud data and create intelligent Plant 3D objects. And so that's another conversation that I have quite often with my customers is when does it make sense to back model and reverse engineer point cloud data? Today there aren't any easy buttons where we can press a button and voila, we have a CAD model of the point cloud data. But there are some semi-automated and some automatic processes out there on the market today that do cylinder detection, for example, that automatically detect all of the cylinders within the point cloud data and will help assist you in creating a 3D CAD model if you need it. But in most cases, you only need a model maybe where you're tying in, maybe flanges and pipes here that you saw earlier. So now we're actually in Navisworks, and if you're not familiar with Navisworks, it allows us to open 3D models of many different formats. I think we support over 50 file formats of 3D models, including Autodesk models as well as some of our competitor products. But we're also able to integrate Autodesk ReCap data inside of Navisworks, and we can clash our 3D model against the point cloud data. So that way we can see where we may have any interferences with the as-built conditions before fabricating and constructing this pipe, for example. So you can see here where I may be running this pipe through an existing, looks like a socket welded elbow there. So it's a little minor error, but obviously we want to catch these errors before we do any fabrication to reduce any rework. We can export these clash results out to a report. So I'm looking at a web page here, a little clash report, and we automatically have screenshots of each of the clashes in this report available to us. Another thing we can do in Navisworks is animate the objects, and we can tie these animations to different schedules, maybe Microsoft projects or Primavera, for example. We can do construction sequencing or some sort of 4D and even 5D simulation if we wanted to simulate cost. But we can tie these animations to clash results. So if I wanted to simulate the removal of this tank, for example, from this facility, I can tie that animation to this clash test, and it's going to tell me, am I going to be hitting anything? So you can actually simulate the removal or the installation of maybe major pieces of equipment into the facilities, leveraging point cloud data. And again, we can export these out to the HTML reports. So that really wraps up what I wanted to show today. I wanted to give you a high-level overview of what ReCap can do in the context of oil and gas within the ReCap products themselves, as well as the broader Autodesk portfolio. As Eric mentioned, if you would like for us to go into more detail on some of the workflows or some of the applications, please let us know, provide us some feedback. You can reach out to myself or the ReCap community here. with that feedback, and maybe we can turn this into a bit of a web series around reality capture and oil and gas, and go a little bit more deep into some of the workflows of those applications that I showed you earlier. Eric, do we have any questions from the audience?
All right. Well, thanks, Cody. That was great. So we have a few questions, and just to add on to what Cody said, definitely send us feedback if there's things that you want to hear more about. You'll also get a survey after the presentation. Please fill that in. That's really useful for us in determining future sessions and all of that. As far as questions goes, yeah, we have a few, and there's still time if anybody wants to ask more. Just type it in there to the question box. For starters, okay, so when you're working with point clouds, Andre would like to know a little bit more about the file sizes we're talking about when working with laser scans.
Sure, great question. Because we're dealing with a lot of data, millions, if not billions of points, these file sizes can be pretty big, and there's a lot of factors that go into how big these file sizes are. One factor is resolution. Each of these laser scanners, when you're going out and collecting data, there are resolution settings on the scanners themselves, so you can set it at a low resolution, a high resolution, a very, very high resolution, and that's going to impact the size of your laser scan files. It's also going to impact the amount of time it takes for scanning. So if you do a low resolution scan, it may only take 1 minute, for example, to capture that asset. But if you're going to be doing a high resolution scan or a very, very high resolution scan, it can take maybe 5 minutes per scan. And then another factor is color. Traditionally in oil and gas, I've seen mostly black and white point cloud data sets. Now I'm starting to see a little bit of color come into these point cloud data sets. I'm not going to prefer the color. I think it gives us a better better context of what we're looking at. Sometimes these pipes are color coded based on their service out in the field. Red for fire water, purple for cyanide or something like that. And so having that color can really help you out. But color is also going to affect the size of your scans and also the time it takes to collect this data. And then different manufacturers of laser scanning hardware have different compression techniques. So some better than others, and so some file sizes are going to be bigger or smaller than others. But I think a good kind of measurement is maybe between 250 and 500 megabytes per scan is kind of the average I've seen. I've seen some scans up to a gigabyte, and it really depends on what file format they're in as well. Some file formats are compressed, some aren't. So there's a lot of factors that kind of go into the size of the laser scan data itself.
All right, yeah, like Cody said, from our end, my group, we're working a lot with manufacturing and such too. So, yeah, file sizes we typically see for, maybe a warehouse space. It's not unusual to go maybe 150 megs or so for an average scan. Upwards to, again, as Cody said, gigabytes or several gigabytes for large projects. All right, let's see. So the web services that we showed, there was a question about what's free, what's paid for. The ReCap 360, the RealView product that Cody showed, that's free to use. That's completely free. You don't have to have a pro subscription to use that. Now the photo service, we have a free version and a paid version of the photo modeling service. So the free version will not give you as many export formats. So if you want to export as, say, a point cloud like Cody demonstrated, you do have to pay for the pro version of the photo service. and that runs, I believe that's $55 a year, so it's not a big investment. But then you'll pay based on the model, so it's like $5, I believe, a per model. And then if you make changes to it and resubmit, it's free for that same model. But yeah, so the pro entitlement for Photo on ReCap 360, that does have a cost associated with it, but that allows you to use the, as Cody mentioned, the full 250 source images, as well as the ultra rendering capabilities and some of the other export formats. But RealView is a free feature. Let's see. Okay, we have a question about, let's see, color and high resolution scans. When importing your laser scan data for a high-res scan and color, is there an import option that works best with distance, decimation, etc.? My last scan was 400 scans, and they take a while to bring into Navisworks 2014.
Yeah, sure. So in ReCap, there are some advanced tools where you can set the decimation value. So 0 being no decimation, it's not going to reduce. It's not going to call out any points, and I'm not sure what the maximum value is, but there's a slider bar in the advanced options of ReCap to set the decimation, as well as some of the filtering, noise filtering, and clipping. So you can clip out certain ranges from the point cloud data as well.
Yeah, just to add on to that, 400 scans is certainly a large project. So, I'm not surprised in any way that that's taking a while to come in. If it's to the point where that's getting too slow, you might try using some regions to kind of optimize things, maybe break the project up into some regions, export them region by region so you can focus on a smaller area. But yeah, if you need the full point cloud, yeah, some of those decimation options might be your best bet, because yeah, you're talking about a lot of data.
Yeah. Another thing to keep in mind regarding performance is where the data is located. If the data is located on a network server, for example, you can experience some latency. If there's a lot of traffic on the network and you're trying to visualize that data and pull it over the network into Navisworks, you can experience some issues there. So I kind of recommend having a local copy of the laser scan data, especially if you're dealing with large data sets. 400 scans, that's a pretty good size job. I've seen upwards of 2,000 scans, but these data sets can be many gigabytes in size, and so if you're pulling that data over a network, you can experience some latency. Also, you want to make sure that obviously your computer or your workstation meets the recommended specifications for Navisworks or for ReCap, for example, especially the video card, because we are dealing and rendering with a lot of points.
Yeah, and that's a great point. When you're working with a lot of data, things like your hard drive matter. So, for instance, even just the difference between solid state versus, a typical spinning hard drive. I mean, things like that can make a huge difference. I think let's go with one more question, and then we'll wrap it up. So this is about the ability to bring point cloud data into Memento, or bringing Memento meshes back into your laser data and combining those. Do you want to take that one, or should I talk about that a little bit?
I'll let you talk about it.
Okay, so as things stand currently, that's not something that we support. So ReCap, for instance, does not allow you to import a mesh, and Memento in its current state only works with meshes and won't bring in point clouds. Now, that said, you can use the Photo on ReCap 360 service to generate a point cloud, which you then can bring back into ReCap join that up with your data that was collected with a laser scanner, and then take that combined model into a Navis or an InfraWorks or something like that. We certainly are working on some of that interoperability. So you will see some of that sort of thing in future versions of the software. But as things stand today, the photo on ReCap 360 into ReCap option via the point cloud is going to be the best way to combine those. So I hope that's helpful. And as Cody said, there are some third-party partners and plugins that will do some of that modeling as well, turning point clouds into meshes. And again, it's something we will be supporting, but it's not available now. So, all right. Well, I think that about wraps things up. Thank you, Cody. It was a great presentation. I hope everybody found this valuable. I can't stress enough, if you have comments, if you have other things you'd like to see, please reach out to us. That's what we're here for. Recap.community@autodesk.com. Send us some feedback. We're doing this for you guys as much as for ourselves. So, if there's a topic that we talked about that you'd like to see covered in detail, if you have an idea for a session, for something that we didn't cover, let us know. We have some upcoming presentations on an introduction to reality computing. What is this concept? We have one coming up to talk about using some of this data coming from Memento and pulling that into a product like Fusion 360. We've got a bunch of stuff in the pipeline, so I hope you guys will join us again. Again, we're going to post this recording on YouTube along with some of Cody's example videos, so you can see them on your own. But otherwise, thank you, everybody. And for those of you in the U.S., happy Thanksgiving, and we'll talk to you later. Thanks for joining.